everybody. It's Georgia Weedman, author of Penetration Testing, a hands-on introduction to hacking, and your instructor for this accompanying lab. So this time we're going to take a look at doing SQL injection manually. We saw SQL injection when we did SQL map, and SQL map did a lot of the heavy lifting for us, but it's always good to know how these things work. So this time we're going to do it manually, and last time I had a terrible definition of SQL injection, so I figured I'd pull up the book so we could get a better one. Best thing about having a book, you can just basically reference yourself for the rest of your life. And basically it says we typically don't have direct access to run SQL queries on a site's backend database from the web interface. Though, don't get me wrong, I've seen it. But usually, our user input is passed back and put into a query that then, goes into the database and gets data and whatnot. But if the developer fails to sanitize that user input properly, which is no small feat, I mean, this isn't just a matter of taking out single quotes. It definitely happens. You may find that you can perform SQL injection attacks, which is what we're going to look like here, and that's going to manipulate the queries. So instead of just, putting text into the username field that goes into select star from users where username equals Georgia and password equals password, semicolon, end of SQL statement, you start changing that around by putting actual SQL commands and syntax into the username field. So instead of Georgia, it would be the ones we're going to use now, for instance, and actually change the query that's run on the backend database. So, the goal as the developer would be to stop that from happening. No matter what a user put in, it would not break the SQL and allow people to change what's actually being executed. Like I said, easier said than done. I mean, there's a lot more to protecting against advanced SQL injection than just taking out just single quote and things like that, special characters. But most programming languages do have things like parameterized statements and things like that have built-in capabilities to help you with the SQL injection issue. But anyhow, I guess I should actually start the lab. Let's drone on for forever and then not have the lab started, which I think this is the first time I've done that in the video. So I guess if we got this far, we're doing all right. So we're going to look at a few different SQL injection examples. You do have additional ones like that vulnerable web app that you have. It has other exercises beyond the ones we're going to do in this lab. There's nothing stopping you from doing the other ones. There's also, nothing stopping you from, grabbing a copy of this on your own machine afterwards and, setting it up and doing it yourself, because we aren't going to, in this class, we're going to do a fair amount of web app, but we're not actually going to do a complete web app course. Well, maybe you guys can be the first to know that after Pentesting V2, I plan to do a series and go in depth with basically each of the chapters. So, if how long it's taken me to do this one is any indication, check back in another 6 years or so and I'll have a series of books out with accompanying labs, and you guys are the only people in the world that know that. Alright, so IP adder. And we want .3 and it's going to be web, so we may as well just forget the nmap part and get on with it. Alright, so it is that bwap, so bbug to log in. Those credentials are right here. Oops. Alright, and we can choose our challenges. So since this is SQL injection, we're going to do, a few of the SQL injection ones. And so why don't we just start with the login form. I mean, logins are a great place to find SQL injection because bypassing login is pretty great, let's face it, as a pen tester. Alright, so this is just a regular login form, but we don't know the credentials. I should probably I'm a superhero, alright? So it says enter my superhero credentials, so I am a superhero, so there. And so are you, because you do pen testing. So it gives me back that those are invalid credentials. Fair enough. But what I want to do is, well, I make the assumption. I mean, you don't have to authenticate off of SQL or any database. I actually did. I think it's in the book. There's an example where they actually authenticate off of XML and it does XML injection. But it's generally probably a good assumption that logins are calling off a database and databases speak SQL and so on and so forth. So what I want to do is kind of manipulate this guy, and I want to say, well, let's just put in a single quote and see what happens, see if we can get an invalid. Yeah, okay. So they're not always going to write out, hey, you have an error in your SQL syntax, but when they do, that's, you've got your SQL injection because you've basically broken the query at this point. The response from the database isn't logging you in, it's the SQL syntax is wrong. When the syntax is wrong, that means you've manipulated the query. I mean, unless the underlying code, the syntax is also wrong, and then, well, that's another story for another day. I have been given applications to test that don't run. Believe me, it happens. But anyway, assuming that login really works, it looks like this does have an instance of SQL injection. And it even is nice enough to give us like part of the query. Again, we don't see the backend query, but a typical login query is like select star from user or whatever the table is called, where login equals Georgia and password equals password. So if there is such a user, it would pull up that data and then, authenticate. But, there is no user Georgia and there is no user single quote, oddly enough. But, typically what we can do for this is say, okay, so we're doing select star. I should write this down. This isn't actually going to be like code, but so it would be something like select star from users maybe not being the table name, but we're not manipulating the table name at this point, so who cares, where username equals Georgia and password equals password. And so that would be a pretty good guess of what the backend SQL is, where we can control what's in Georgia and we can control what's in password. So what I did in this case, when I just gave it a single quote, it came out like this. And so I was telling it, I mean, I guess it's possible in some scenarios that I can't think of that a single quote could be a valid username. But I said username is single quote and password is blank. And instead of saying there's invalid credentials because there's no user named single quote with a blank password, it's instead seeing that single quote as like the single quote after it. So this becomes like this becomes a syntax error, basically, just like it said. So the syntax is now wrong and it's not able to execute. So our goal would be to take this from, this is denial of service basically, to now we want to make it actually execute code that we want. And since it's a login page, we want to bypass login. So what we can do for something like this is we can do the single quote. So it closes. So we can do, I've confused myself now. So we can do, let's just do it over here and then I can copy it in because it'll be easier for me to read. So we could do, one close, or we could just leave it blank, it doesn't matter, blank username, and then we could do 1 equals 1. So what is 1 equals 1? Well, it's true. So blank or true. So username equals blank or true. Everybody has a username, so everybody would be valid there. And you can do the same thing for the password. And the fact that I can't see it pretty much guarantees that I'm going to have syntax errors. The problem with this, though, let's look at what happens, if we put it into our actual query. So if we do close or 1 equals 1, I think I actually, because they're strings, so if it's an integer, you don't need quotes around it. If it's a string, you do. So what we would actually do is this. And depending on it, you may have to fool around with it a little bit. So close single quotes or 1 as a string equals 1 as a string, but without the closing quote. Why not the closing quote? Because if we look back to our original query, there's basically we replaced the closed quote that's already in there with this one. So if we put a closed quote at the end here, again, we've got broken syntax, double quotes there. So we're just going to leave that one off. And then, the same thing for the password. It's, so blank or 1 equals, and again, don't put the end quote there, and that should come out. So let me rewrite this with the quotes in, or I can already tell I mistyped that, or 1 equals 1. Login. And sure enough, welcome Neo. How are you today? This is what I don't get. Why didn't I took that black pill? Because there was no black pill. So, but okay, that's another story for another day. I haven't seen The Matrix in a really long time, but yeah, it's red pill and blue pill, not black. I don't know. So anyway, yeah, that got us in, and again, if we look back at what the query was, all we did was say select users from username where username is blank or 1 equals 1, and 1 equals 1 is true. So blank or true, only one of them has to be true. One of them's always true. So username is true. Boom. Same thing on the password side. The main part being that we didn't put the end quote on the second one, because that quote was already in there from the SQL statement. So, to make it even easier, we can actually use SQL comments. So we could do or 1 equals 1, and then we do close it in this case, and then do #, because everything after the comment, including like the whole password field, is going to be treated as a comment, so it won't be executed. So since we lost that extra single quote, we had to put it in. And sure enough, once again, welcome Neo. So, you may be able to, instead of fixing everything to be right, you can just basically make the first one work and put a comment in and comment out the rest of the SQL query. So, doesn't seem too hard. Certainly it can get harder, but, that's how SQL injection works, really, is that you're manipulating the query. So, where problems tend to happen in general, I guess, with software, but certainly with web apps, is where users are able to put in data, making sure that data can't harm the website or the database or whatnot. So let's look at a couple more while we're here. And so, one we already saw in our SQL map injection was the get. We already saw the get search one. Let's do the get select. All right, so what this one does is you select a movie and click go, and you see up here, like, we chose movie 7. So it isn't particularly exciting. But if we set, movie equals 1, or let's type it right. And because that's an integer, this time we shouldn't need the quotes around 1 equals 1 because they're numbers. So movie equals 1, close. No, it doesn't have quotes around it either. Or 1 equals 1. Let's see what happens with that. I'm sure I busted it somehow. So again, just gives you the first one, because clearly the way this table works, it's only designed to show you one. But what you can do is you can use the limit command. And so if I say like limit 2 and the first one after it, this is just SQL syntax, then it throws, Man of Steel. If I do like limit 3, Terminator Salvation. So we're able to pull out, you can get all this data just by going to them. But, if we didn't have access to all of them, we could do, again, or 1 equals 1 to make it true. So movie is 1 or 1 equals 1, but then move it, to with the limit. So not entirely terribly exciting since we already learned how to do it. Let's do one more. I want to show you a post one, because with these get request ones, we can just manipulate the URL. With post requests, it's in parameters that aren't in the URL, hence more secure. But let's see how we can deal with that. Let's do post search. So this is the typical search for a movie one that we saw for our SQL map one that we did earlier, but now it's a post request. So what I want to do, turn on my burp proxy with our Foxy proxy, go down to our Dragon web application analysis and burp suite. You can just go through the defaults to set it up. Yes, I know it's old. And then send in Georgia. All right, and our proxy catches that, and what I want to do is send it to the repeater so I can mess with it, send different stuff. So if I do, for title, instead of Georgia, just a single quote, and send it, I get a nice SQL error over here. Error, you have an error in your SQL syntax, blah, blah, blah. So it looks like this is indeed vulnerable to SQL injection. We have indeed busted it. So, we want, so it is going by title. Remember, this time it doesn't look to be by number. It was sending title equals Georgia. So if we did, empty title or 1 equals 1, and see what happens then. This is why repeater is cool. I can just keep sending the same thing. I can make changes to it and it'll show me the response. I don't know why I keep pointing at the screen as though you can see it. And this time it looks like we did not get that error, so that looks like a pretty good indication that this is correct. So what we can do is copy this back over to our proxy and replace it here, which I'm sure there's an easier way to do that I don't know. And if we forward the request back, sure enough, we get everybody. So it dumped me the whole table. It didn't in the previous one. The way the table was rendered, it was to show one at a time, whereas this one, it will, show us all of them. And sure enough, it did. So basically, consider this dumping the database. So, we use SQL injection to bypass a login. We use SQL injection to see stuff we weren't supposed to see from the database, or dump the entire database. So again, those are just a few examples. And again, if you have a post request, you can, manipulate it using Burp Suite or some of the other proxies. And yeah, that's all for SQL injection. The main point is that, a lot of websites do have backend databases. They are doing queries on them. They are often sending user information into those queries. And if SQL injection is there. You can manipulate the query just by manipulating the SQL syntax to make it do, all sorts of things. This is really just scratching the surface on, what we can do potentially. I mean, you in some cases can bring down the system. You can execute commands on the underlying system in some cases, XP command shell and things like that. And databases are often running a system, and we know that things that are running a system are great. So, there's really a lot you can do with SQL injection, but that's what we will stop with for now. And I encourage you to continue your journey with it, play the other examples, have fun.